Now for question number 12, this question. Now you may feel like this question is like something like this. Okay, you may feel like it's something like this. All right. So yesterday or in last Thursday we talked about how we use the 3 to the x as a unit, right? Like for this one, it would be like 3 to the x squared minus 10, 3 to the x plus 9, and I'm going to use a dummy variable in place of 3 to the x. Well, that's number 11. Now, for number 12, then you're like, wait, hold on. Something it's different. This is just 2 to the x. That is not 2 to the x squared. What do we do? Well, and then what makes it even more mind-boggling is this: 2 to the negative x, and be aware that your mind, whenever your mind feels, your brain feels stressed, okay, or panicky, your brain starts to do all kinds of random things that that's not supposed to happen. So first, can you interpret properly what this negative means? It means what? Put it over, not put over 1, but one under 1. So so the proper way to interpret this negative is this. All right, rules are still rules. Okay, it won't change just because things look weird. And now we will still employ the use of a dummy variable to make life a little bit easier. So like this. So it's a strategy that we used before, which is, do you like fractions? You don't like fractions, right? So how do you get rid of the denominator a? What can you do to get rid of the denominator a? Multiply by a on both sides. You simply multiply a on both sides, and then you will get rid of a. So so we can do something like this. You just multiply a on both sides, and again, you do on both sides. So you distribute. So a become a times a squared. The a got canceled out. So and then minus 9a. A times 0 is 0. So now you have your quadratic equation. So you have a squared minus 9a plus 8 is equal to 0. So now, and the rest will be very easy. I would finish the rest in a moment. But what I want you to see is that when you see there is a denominator, it is about the strategy. Do you know how to handle the strategy? Or do you know how to handle the situation? Do you know what strategy to use so that you can work with something that does not have a denominator? Multiply the denominator on both sides. So what's the rest? The rest is simply a minus 8 and a minus 1. It's equal to 0. So therefore, a is equal to 8 and a is equal to 1. And we say, what's a? 2 to the x, right? So 2 to the x is equal to 8. 2 to the x is equal to 1. So x must equal to 3. And x must equal to 0. Okay. So every single question that you see, all right, from now, well, since last week, every single question that you see, you must ask yourself, what is the most immediate thoughts that you have? What's the first step? What's the second step? If you can voice out the first step and second step, then you will be good. Yes. Just not use a dummy variable. Just keep it as 2x squared, 2x parentheses square. So that's what I said about the pre-calculus way. If you don't use a dummy variable, then what you would do will be this. Go ahead and erase this part. If you do not use a dummy variable, then all you would do is this, okay? You simply go ahead and multiply 2 to the x power on both sides. Then you have 2 to the x squared plus h minus 2 times 2 to the x equals 0. So in your mind, if you say I don't use a dummy variable, that's fine. You just go ahead and make sure that you are viewing 2 to the x as a single entity. And use 2 factor the same way. So 2 to the x, 2 to the x. That's how you get 2 to the x squared. And then 8 and 1, and both negative. So this is what I would expect for students in pre-calc. That's a more sophisticated way to show your work. And in calculus, you would definitely not use a dummy variable. Yes?
Can you please explain why the number raised to the 0 power equals 1?
Yeah, sure. The question is, how come anything raised to the 0 power, it's 1? I'm more than happy to explain it. All right, so if I give you this, I'm sorry. What's the answer? A squared, right? Why? Because a times a times a times a times a over a times a times a. They cancel each other out, so what's left? A squared, right? And that's how we generate the rule. We say, oh yeah, when you have the same base, the number having the same base, and they're dividing, you will subtract the exponent, right? What's this? Because they all cancel each other out. And if you think about the rule that we just came up with, what do you do with the exponents? Therefore, it's a to the 0 power. Okay. And while we're at this, let's just go ahead and explain one more thing. What about the negative exponent? How come a negative exponent is 1 over? How come it's reciprocal? Well, what about this? This is a times a times a times a, right? So they cancel each other out, so it's 1 over a. And when you subtract the exponents, what do you get? Everything can be explained. And that was a moment I realized that math actually has a face that's waiting for us to explore. But some teachers, not me, some teachers, they would just tell you that negative exponent means reciprocal, but they never explain the why. Anything raised to the 0 power, it's 1, but they never understand, they never explain the why. So that's the reason right here. Good. I hope this resolves some of your mystery about why anything raised to the 0 power, it's 1, why negative power means reciprocal. There's always a reason behind it.